Hey guys, I am on page 6 of 6.2 today. It's a check your understanding question. Today it's a large auto dealership keeping track of number of cars sold each hour and number of cars leased as well. And this first question, we're given a lot of data here in this table. But first question we're asked is to interpret the mu of t, and t is defined up here as x plus y. So we've got these two random variables. X is defined right here, y is defined right here. X is cars sold, y is cars leased. So basically t is, in words, number of cars leaving the lot, whether it's sold or leased, per hour of each day. So I'm going to first define or find in the mu of t by adding the two means together, this mean and this mean, and then we're going to interpret it also. So this very first question, find and interpret the mean. So you guys remember that from like chapter 1, we're able to add means together. We've got 1.1 car, so just over one car, and I did speak wrong. It's during the first hour of business, so like right when they open. 1.1 car being sold in the first hour on a randomly selected day, and then 0.7, so just less than one car per hour leased, and we add those numbers together, we get 1.8. The interpretation is, if I randomly select a day at this dealership, we expect about 1.8 cars to be leaving the lot, that means leased or sold, in the first hour of operation. And so remember that when we're doing question number 2, computing the sigma of t, remember that you can't add standard deviations together. We talked about in class how that's like adding square roots together, which you're not able to do algebraically. So same thing here, remember we have to add the variances. So what I have to do is take this standard deviation and square it, and I have to take this standard deviation and square it, and that's what I'm able to add together. So I get a total variance, and then of course square root that to get the total standard deviation. So what that's going to look like is this. I've done my sigma t squared, which represents the variance, is the variance of the x plus the variance of the y, or the standard deviation squared plus the standard deviation squared. And then remember, that gives me the variance of the t, so in order to find the standard deviation itself, I have to square root that number, and that gives me about 1.14. So remember the interpretation, that's the same interpretation of standard deviation from chapter 1. It's the expected difference between the average number on average, or the mean on average. So we expect and then just add in the context, number of cars sold or leased in the first hour on a randomly selected day at this dealership, to differ from the mean. That was this number up here, the 1.8. It differs from the mean by about this much on average. So make sure you've got some keywords here. About is an important word. On average is important. We expect it to differ from the 1.8 by about this much. So a couple important things just to make sure you remember to put into your standard deviation interpretation. Okay, and then the last question says the dealership's manager receives $500 bonus for each car sold and $300 for each car leased. So perks of being a manager, you get a bonus when your sales dudes do a good job selling. And so if we can expect him to get $500 per car and $300 per leased car, we have the averages already. Those averages are up here on how many he gets per hour. So we can find the mean by just taking the 1.1 cars we expect him to sell and multiplying by 500, and taking the 0.7 cars we expect their dealership to lease and multiplying that by 300. That part's the easy part. The standard deviation is going to be a little bit harder, so I'm going to do the mean part first. So here's what my work looks like for finding the mean. Make sure, even though I know you could probably do this in the calculator all at once, it's always a good idea to show your work, even if it doesn't specify to show your work. So I'm taking 500 times the mu of x plus 300 times the mu of y, and then plugging those numbers in, and it gives you 760. So just remember, when you do standard deviations, we can't add standard deviations together. We have to add variances. So it's going to look something like this, but I have to use the 500 and the 300. So here's what that standard deviation calculation is going to look like. So look really carefully. When you're taking the 500 and you're multiplying it, because we're using a variance here, notice how I also have to square the 500. Same thing with the 300. I'm using a variance here, so if I just strictly multiplied by 300, that wouldn't be enough for my calculation. The dollar amount wouldn't make sense. Like, for lack of a better analogy here. What I like to think about it in terms of is keeping the units the same. Everything that I'm using here is squared. And so if I'm going to have a constant that I'm multiplying by, I also need to square that. Otherwise, mathematically, my numbers won't make sense. So try and think about it in terms of that. Make sure that you're keeping your units the same. Everything there is squared. And then remember, when I do this, when I add these variances together, I'm going to get a variance. And so what I have to do is square root that answer at the end. So make sure you're okay and you're comfortable with this. This is a really, really big like common mistake that happens a lot. So I'm going to put like a little asterisk here, a little caution. That's a big mistake, is usually forgetting to square also the multiplier. So there's actually a continuation down here. The same exact problem dealing with the auto dealership and the cars leased and the cars sold, but this part is saying define D, I'm assuming D for difference, equals X minus Y. So think about what that would mean in context. That is the difference between the number of cars sold and the number of cars leased. And the direction is important here. Because they're selling more cars than they are leasing, we're going to get a positive number. But it would be different if it was Y minus X. That would be leased cars minus sold cars, and we would get a negative number. So just make sure it's really important when you're doing your interpretation, which I'll get to in number 4, that you always specify in subtraction which way that you are subtracting. So find and interpret the mean of D. You could probably do that part in your head. I'm just taking this mean, the mean cars sold and the mean cars leased, and subtracting them, and we get 0.4, and then I'll write out the interpretation. So here's that number, that 0.4, and then just check your interpretation. It's pretty similar to the one we wrote above for problem number 1, but this one's a randomly selected day at this dealership. We expect the difference, because this is subtraction, between sold and leased cars to be about 0.4 cars. And then, like I said, you have to always make sure that you specify which way you're subtracting anytime you have a subtraction problem, just to make it clear. So computing the standard deviation of D, remember we talked in class about why this, assuming X and Y are independent, otherwise we wouldn't be able to add them together or subtract them together. And by them, I mean variances, because we can't add or subtract standard deviation. But actually, if you look at, there's a section in the book, which you should have read about, on page 371. There's this whole explanation about how even though we are subtracting something, we still, our data gets more spread out. Anytime you combine two different data sets, so like sold cars and leased cars in this case, when we're combining them, regardless of whether we're adding or subtracting, we are always going to add the variances no matter what. And so that's a little bit confusing, and to save time on this video, I refer you back to page 371, because there's a lot of verbiage and interesting examples and things to think about on that page regarding the math behind that. So here's what that is going to look like, and I made a little note about making sure that we're still adding variances even though this is a subtraction problem. So actually, this is the same exact thing as what we did way up here. Notice how we have the same exact number. So yeah, it's not any different. Anytime you combine, whether you add or subtract, two different distributions, your standard deviation is going to get bigger. Your data gets more spread out because you are combining, whether you're adding or subtracting. So that's a little bit confusing. Go back to page 371, but make sure that even though that you know this is a subtraction problem, yes, we still add variances and we get the same number. So the last part just says this dealership's manager, again, we've got 500 bonus and 300 bonus for sold and leased respectively. Find the mean and standard deviation of the difference. So I'm curious, can you think to yourself if anything is going to be the same as what we did up here? Or what's going to be different? This is almost the exact same problem, except here we added together and now we're subtracting. So look at step number 3 with all these bonuses that this guy is talking about. What is the only difference that we're going to have here? So we want to know the difference between how much he makes on the sold cars versus how much he makes on the leased cars. So I'm going to change this to a negative sign. Otherwise, same exact number, same exact everything. And then in terms of standard deviation, yes, we're multiplying, and yes, I need to keep the units the same like we talked about here, but even though it's a subtraction problem for standard deviation, we're still going to add. You guys, this number is going to be the exact same, so I'm going to copy that down real quick. So here we got it. Making sure you show your work, even if the directions don't specify that. This is the same exact thing as up here, except I am adding up here because I want to know how much total he makes in a bonus. This question, the only difference is what's the difference between what he makes cars versus, or sold versus leased, and that's how we get $340. He makes an additional $340 total in this first hour with those two means that we were given on the sold cars than he does on the leased cars. But then what's the spread of that? What is the standard deviation of that? That is the same math, and notice the same exact answer as up here. Some things to note is to make sure that you are keeping your units consistent here. So we're squaring the 500 and the 300, those bonuses, because we're working with variances. And then remember, when you add those squared numbers together, it actually gives you a variance. So don't forget to square root your answer at the end to get back down to the standard deviation. That is all for today. We're going to do a worksheet on this stuff tomorrow to make sure it all sunk in. So you'll be working in groups and you'll have an opportunity to ask questions. So bring those to class tomorrow. Thanks for watching. I'll see you later.